So while waiting for the others, you guys have a question or a clarification? So grab this opportunity now to ask question. So this is now your chance.
Sir, ano po scope ng exam?
Scope of your exam is as usual. Whatever are the topics that we have covered. So yeah, module 1 up to module 2, since those are the only topics that we have covered. So we will finish this module 2 now. So you only have 2 modules to review. So that's the scope.
Thank you, sir.
Okay. So no exception for the topics. So everything is covered. So review everything. 15. So last 1 minute. So before we were 18, so I don't know what happened to the other 3. Mr. Abdul, are you there?
Yes, sir.
Can you follow so far?
Yes, sir.
Were you able to understand my way of explaining things?
I just need just some practicing,
Practice.
and I will be all able to understand it all.
All right. So if ever that you have a question or clarification, so don't be shy to ask your question. Okay.
Sure.
All right. Okay, so it's already 4:55, so waiting time is over. So we are now total of 16. So I don't know what happened to the other 2. Anyway, so don't you guys have a question with this one anymore? On how did we prove that this left side expression is equal with the right side expression using a Venn diagram? Should I take that as none? So no question? All right, since no one is speaking, then I'll take that as none. So no question. All right, so we have here another example. So proving example, wherein we have to prove that this left side expression is equal with the right side expression. Okay. So here's the solution. So just copy whichever part you wanted to prove. So in this part, we have started with left side expression. So we have to come up with this right side expression using this expression. So the first thing that we did in here is, is mixed with annotation expression wherein x is an element of A, intersection B, union C. Okay, I was about to say and then or. Okay, but in here in module 2, we call this one intersection and then union. Okay, then after that, okay, so what is the next thing? So yeah, this one now is now converted into loss of logic, wherein intersection is equal to end. Right? So x is an element of A and x is an element of B union C. Okay. So this union is equivalent to or. So that is why we now have this kind of expression wherein we just distribute this x element inside or this closing up in parentheses. So x is an element of A and x is an element of B or x is an element of C. All right. And then distribute again this one, okay, into our close and open parentheses. So we now have here x element A and x element B, which is now this one. And then the next one here is or x element A and x element C. Okay, so I'm skipping the word is an element to make it shorter. Okay, I'm just reading this one element. So from here we have now arrived to here. So we've just used distributed properties. Okay, and then from here we can now call this one remove the notation. Okay, so just remove the x element. So just retain the A and then transform this back from end into intersection, and then just remove this one and then B. And then this OR is union, and then again just remove the X element, and then we will now have A, and then this end is intersection, so just put here intersection and then C. All right, so that's how we prove that this left side expression is equal with your right side expression. So did you guys understand this one? Step-by-step solution?
Yes, sir.
Or just a little?
Medyo, sir.
Medyo. Okay.
Medyo lang, sir.
It would be better if you would be honest with your answer. So I won't get angry even though you're going to say, sir, I didn't understand anything at all. Could you please try to explain it one by one? Okay, so I'll be gladly to help. Okay, so no problem with me. Okay, so do not fake your answers. All right, so we have your proving example number 3. So we have to prove that this A intersection B is equal to A union B. Okay, so as you can see, this one's like big complement. So what is the opposite of intersection? Of course, union. Okay, so this one is super similar with the laws of logic. So from here, we have to prove that this left side expression is equal with the right side expression. So we just copy this one, and then again, just add the notation like X is an element such that blah, blah, blah. So X is not an element of A intersection B. So this not here is the entire negation. Okay. And then we've now like put the negative outside and then retain the X element A intersection B. And then from there, we have transformed this intersection into end. Okay. And then it's like distributing this X element into this expression or closing up in parentheses. So X is an element of A and X is an element of B. And then from there, we have distribute, okay, this negated symbol. So X is not an element of A, and then this N became OR, and then X is not an element of B. And then from there, we have just distributed this one into our set. So X is an element of not A, or X is an element of not B. And then from there, we can now put this one inside a close and open parenthesis, wherein X is an element of not A, and then this OR will now become union. So just, put it back onto its original properties. So not A, union, not B. Okay, so in that case, just remove this notation, X element, then this now is equal with your left side expression, or this one. So did you guys understand this one? Or just a little?
Nakuha naman, sir.
That's good then. So the one that we're doing here is the way of proving things when it comes to language mathematics. Okay, module 1, that's with the use of loss of logic. Yeah, loss of logic. Okay, but this one is using set and etc. That is regarding with sets. All right, so we have your proving example number 4. So I will not explain this one to you anymore. So this is the last proving example. Okay, so I will leave this one to you as your self-study assignment. Okay, but of course not graded, since this one is just an example. Okay, and then after you have fully understand the proving example number 1 to number 4, then here's your sit rate for this one. Okay, so as you can see, there should be 2, okay, sit rate, but this number 1 is the same with example or proving example number 2. Okay, so you can just simply ignore this one and then just answer the number 2. So just one number for this sit rate. So take note, this one only, okay? This number 2. and then put this. Is it possible? I guess no. All right, so just do this one handwritten, okay? Since it's quite difficult to do this one in a Microsoft Word, especially this complement. Okay, so for symbols, it's easy maybe, but for this complement, so it's quite difficult. Anyway, so just do this one handwritten, and then please write legibly, and then take a picture of it clearly, okay? So I can see it clearly, because if I cannot see it clearly, then I might just, make it incorrect, okay? And then you will get nothing. Right, so please write legibly and then take a picture of it clearly. So any questions so far regarding with the secret? Question or clarification?
Sir, pwede po i-scan?
Scan?
Yes, sir.
Yeah, pwede naman. But with the use of your phone, so the same, it's like taking a picture. Or maliban na lang kung, so if you have your own printer, then yeah, you can literally scan it. So you can have a better clarity of image.
Thank
So
you,
yeah,
sir.
any other concern? All right, so I guess none, since no one is speaking. So again, just answer this one, okay? Number 2, okay? Just remove or disregard this one. All right, so we have here Cartesian product, okay? So in Cartesian product, just simply the multiplication of this ordered pair to this ordered pair, okay? So for example, let x and y be sets. So the Cartesian product of x and y can be written as x times y. So it denotes the set of all ordered pairs x, y, where x is an element of x, and then y is an element of y. And then just take note that the ordered pair of elements written as AB is not is considered distinct from the ordered pair BA, meaning this AB is not equal or not the same with BA. Okay, because your first ordered pair in here, or the first element, okay, in ordered pair is your x coordinate, and then the second one is the y coordinate. Okay, so in other words, actually we call this one domain and then the range, and then this is again another domain and then another range. Okay, or the other terminologies says that this one is the domain and then this one is the codomain. Okay, at the end of those, they are just the same. And then so of course credits to Mr. Rene Descartes, since he's maybe the one who contributed with this Cartesian product. Okay, so he's a mathematician who's involved with this Cartesian product. Okay, so let's have example number 1 for the Cartesian product. So we have this set and then another set. So we have set x and then set y. So for set x, we have 1, 2, 3, and then set y, we have AB. So we have to find the x times y. So again, this one is super simple. Just multiply the two coordinates or the two set. So as you can see right here, just use the FOIL method. Okay, so we have 1a, 1b, 2a, 2b, 3a, 3b. So it's like distributing. Okay, so these are all of the ordered pairs of x times y. How about y times x? Okay, so in this case, just make your y in here your domain and then your x as your range. So this one first before this one. So A1, A2, A3, B1, B2, B3. Okay, simple as that. And then for x times x, so just multiply it to itself. So we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and then 3, 3, which is now this one. And then for y times y, so just multiply the y to itself. So we have AA, AB, BA, and then all right. So that's how a Cartesian product works. Okay. So again, just take note again that x times y is not equal with y times x because they have different coordinates, or they have different domains and then range, right? And then if you want to get the cardinalities of x times y, so you can just simply get the cardinality of your let's say this set, and then the cardinality of the other set. So just multiply them. So as you can see right here, we have 2 and then 3. So 2 times 3 is 6. So this count is 1. So 1, 2, 3, 4, 5, 6. So yeah, that's how you identify the possible combinations or elements of those two ordered pair. Right. So any questions so far regarding with this one?
Wala,
Hello?
sir.
You guys still there? Okay. So again, if you have a question or clarifications, don't be shy to ask, okay? So we have here another example wherein if restaurant serves 4 appetizers, so we have ribs, nachos, shrimp, and then fried cheese, and then 3 main courses, we have chicken, beef, and then pork. So the question here is how many possible dinner combinations which consist of 1 appetizer and 1 main course? Okay, so you can have ribs chicken, ribs beef, ribs pork, or nachos chicken, nachos beef, nachos pork, or shrimp chicken, shrimp beef, shrimp pork, or fried cheese chicken, or fried cheese beef, or fried cheese pork. So just add all of those, and then you can now get 1 appetizer and then 1 main course. But since we have this formula wherein you just need to multiply your cardinalities, so A times M, so we have 4 appetizer and then 3 main courses. So 4 times 3, we have 12 possible dinner combinations. Okay, so did you guys get this one or no?
Yes, sir.
Baka napipilitan lang kayo para mag-proceed tayo sa next slide. Anyway, so I really hope that your answers are real, not fake. Okay. Anyway, so that's it for example number 2. And then we have your example number 3. So find x times y times z. So where is our x? So we have 1, 2. And then where is our y? It's AB. And then where is our z? It's alpha and then beta. So all you have to do is just multiply this x to y and then z, okay, in all possible combinations. So we have 1a alpha, 1a beta, 1b alpha, 1b beta, 2a alpha, 2a beta, 2b alpha, and then 2b beta. Or just simply multiply the counts of elements of each ordered pair so that you can get all of the possible, or the counts of all the possible combinations. So 2 times 2 times 2 is 8. So if you're going to count this 1, there's also 8 possible combinations. Right. So that's it for example number 3. And then we have here another example wherein this one is null. Okay, when you say null again, there is no element inside of it, or just an empty set. So an empty set contains 0 elements. So any number that is multiplied to 0 is of course 0. So in here, we're just trying to say that if you want to get all the possible combinations, but the other set is like there is no element or there is no coordinate, then you'll get nothing, okay, which is 0, right? And then once you're done in understanding those examples and those concepts, then you may now start and answer these secret concepts. So all to do is find B union C, B intersection C, and so on and so forth. So here are the sets or the elements of those sets. So 1 to 10, 2, 3, 6, 8, and then 3, 5, 4, 8. So I'll give you guys 10 seconds to look onto this one. So do you guys have a clarification or question so far? Hello? Can you guys still follow? sure where you guys lost and now super confused.
Na-analyze pa, sir.
Okay. So if you can do this one using Microsoft Word, then please do so. But if you cannot do it completely using Microsoft Word, then feel free to do it handwritten. All right. Just make sure that you write it legibly so that I can understand it properly. Is it okay now?
Okay na, sir?
All right, so just analyze this one again once you are now really going to answer this one, okay? So we have here the next topic, which is the inclusion-exclusion principle, okay? So under inclusion-exclusion principle, we have 3 theorems, okay? Wherein each theorem has their own condition. So for first theorem, okay, if A and B are finite sets, so you can use this theorem number 1 if A and B are finite sets. And another thing here in theorem 1 here is if there is only 2 variable. Okay, this one is possible if there is only 2 variable. Okay, but if there is 3 variable, then you cannot use this theorem number 1. So here's the formula for theorem number 1, wherein we're trying to get the cardinality of A union B. Okay, so if you're going to expand this one, so A plus B minus A intersection B. Okay. So we'll combine everything and then remove their common elements. So in here, yeah, it's quite logical because it's A union B. So here's the Venn diagram for theorem number 1. So for theorem number 1, you're trying to get the total cardinalities or the total elements of those two sets. Okay. So for you to appreciate this one, let's proceed to the example. Okay, so we have here 2 sets wherein A is A, B, C, D, E, and then B is C, E, F, H, K, M. So we have to prove that A union B is equal to A plus B minus A intersection B. Okay, so here's the solution. So A union B is A, B, C, D, E, F, H, K, M. Okay, but of course, upon doing this one, you have to remove the redundant elements if ever there is. In here we have C and then E, okay? And then the rest are just distinct elements. So if you're going to count the cardinalities of this one, then we have 9 elements. However, if you want to follow the right side expression, so the cardinality of A is of course is 1, 5, and then the cardinality of B here is 6, which is now those 2. And then A intersection B is, so just simply take a look on each of those elements. So how many elements wherein they have in common? So if you're going to take a look at this one, so again, they are common in element C and then element E. So that is why we have 2 elements, which is C and E. All right, and then just simply put the each corresponding numbers. So A and B is 9, and then A is 5, B is 6, and then minus 2. So if ever you can solve this one, so they should be equal to each other. So A union B is 9, and then this right side expression is also equal to 9. All right, so in that case, we're now able to get the total distinct elements of those two sets. So you can use either the left side expression or the right side expression. Okay. So were you guys able to understand this one in using theorem number 1? So theorem number 1 is the simply A union B. Are you guys still awake? Are you guys still listening?
Yes, sir.
Yes, sir.
Yes,
So,
sir.
how is it?
Yes, sir.
Guys, follow.
Yes, sir.
Nantok kayo Bale, bear with me. We now only have 8 slides. So this is for the theorem number 1. We have here another example for theorem number 1 so that you guys know where to use such theorem. So a computer company wants to hire 25 programmers to handle systems programming and 40 programmers for application programming. So of those hired programmers, 10 will be expected to perform jobs of both types. Okay. So the question here is, how many programmers must be hired if those are the count of people that will be needing? So here's the solution. So let A be the set of system programmers, and then let B the set of application programmers. And then we have here the A intersection B, which is both will perform both types of job. So at the same time, he is a system programmer and then an application programmer. Okay, so for you to be able to get the total distinct count of programmers, so you have to apply the theorem number 1. So in here, the right side expression is more useful. So letter A is 25, which is for the system programmer. And then letter B here is the 40 programmers. And then just remove the common elements, which is the A intersection B, which is the both will perform both types. So 25 plus 40 minus 10 is equal to 55 programmers. Okay. So these are the total programmers that we need to hire for us to have or to fulfill those counts of applicants or programmers. So were you guys able to follow at least 20%? So before we were 50-50, maybe right now just 20%.
40, sir, 40.
40%, okay, that's good. At least there's 40%, almost 50%. So again, the essence of this theorem number 1 here is to get the total distinct elements of both set, okay, which is now applied to sample problem number 1. All right, so let's proceed to the theorem number 2, which is if A and B are disjoint sets such that A intersection B is equal to null, then you can now use this theorem. Okay? So they must be disjoint, meaning they have or they must have their own distinct elements. Okay? They must not have common elements. That's why A intersection B is null. So there should none. Okay. So we have here an example. Let A B, C, D, and then B here is E, F, G. So this one is like super simple. It's like, you know, call this one needless to say. Okay. So they have individual elements and then individual elements. So just simply add those two, and then that's now the total count of elements. So 4 plus 3 is equal to 7. So in this case, if ever you want to get the total count of elements, but they are completely distinct with each other, so you can apply theorem number 2. All right, simple as it is. So here's the, all right, so no more examples for theorem number 2 since this one's super easy. And then theorem number 3 here is let A, B, C be finite sets. So in theorem number 1, so let A be finite sets only. But in here, we now have 3 variables. So if that's the case, then we have to use theorem number 3, wherein it has a longer right side expression. But in left side expression, so just simply the combinations or all of the individual or distinct elements of your 3 sets. So A, union B, union C. So in expanded version, we have this one. So I'll leave this one to you guys. So I will not explain one by one on how did we come up with this one. All right, so we have here the example, A, B, and then C. So find A union B union C. So A, B, C, D, E, was it able to answer? All right, so there is also no answer for this one, okay? Anyway, just by simply following this one, then you will be able to get the total count of distinct elements for this one, okay? So I'm sorry I cannot give you an example for this one anymore, or the solution of this example, since we don't have enough time anymore, okay? So here's the sample problem number 2 for the theorem number 3. So before we only have 2 sets, but in here we now have 3 sets. Okay, we have the bus, the train, and then the automobile. So in here, a survey has been taken on methods of commuter travel. So each respondent was asked to check bus, train, or automobile as major method of traveling to work. So more than one answer was permitted. So the results reported were as follows. So for bus, we have 30 people. For train, 35. For automobile, we have 100. And then for the both bus and train is 15. Both bus and automobile is 15. And then both train and automobile is 20. And then all of these methods are 5 people. So the question here is how many people completed a survey form? So since we now have 3 individual sets, so we now have to use theorem number 3. Okay, so A unions B union C. But in here we'll just use the name of the set. So B is for the bus, and then T for the train, and then A for the automobile. Okay, so B here is 30. Train is 35. A is 100. B intersection T is 15. B and A is 15. T and A is 20. And then B and T and A is 5. And then just simply, or just by simply following our right side expression formula, then we will be able to solve the total people completed this survey. Okay, so I will leave the analyzation part with you guys. That's how we've got this number or this result 120. Okay, so we now only have 4 minutes, so I'm really sorry since we are in a hurry. Okay, so we have to finish this one in 4 minutes. So that's it for sample problem number 2. And then for sample problem number 3, so we have here the total already, which is the left side expression, 260 college students. The following data were obtained. So we have 64 for math, 94 for comsci, 50 for business. And then both math and business 28, both 26 and math and comsci 26, and then 22 both comsci and business. So as you can see, we have 3 total individual sets. We have the math, comsci, and then business. So here are the questions. How many students were surveyed who had taken none of the 3 courses? Because out of 260 college students, there were actually students who didn't enroll anything. Okay, so you have to find that count of students. And then for letter B, of the students, how many had taken only comsci course? So don't get confused with this one. This comsci is with the combination of other 26 in here. So this is not the individual total students who have only taken comsci. All right, so those are the questions, and then here are the we call this one the given formula. Okay, and then their answers. So again, we will not be able to answer this one since we don't have enough time anymore. So last 2 minutes. So I really am so sorry since we are in a hurry. Okay, unless you guys would like to have a part 4. Who wants to have a part 4? None. Right. So I will leave this sample problem number 3 as your self activity. Okay. So I would like you guys to figure out how many students who have taken none and then students who have taken only comp sci. So once you're done in understanding sample problem number 1 to sample problem number 3, then you may now proceed in answering this quiz number 2. All right. So we have here a total of 5 questions, and then here's the sample problem. Okay. And then again, you can just analyze this one once our discussion is done. All right, so that's it for this module 2. So we were able to finish this module in just 3 Zoom meetings, okay, but in a fast way, in a fast mode of discussing things. Anyway, so any other concerns so far aside from inclusion and exclusion principle? Hello, are you guys still there?
Yes, sir.
All right. Anyway, so I apologize for that one since we wasn't able to finish this module 2 completely. Okay. So yeah, that's it for module 2, and then we will not be meeting this coming Wednesday anymore since I'll give that one as your free time to finish everything and then review for your midterm exam. All right. So if you guys do not have a question anymore, then see you guys next week. Okay, and then good luck to your midterm exam. And then feel free to ask me anytime you have a question or clarification. Okay. Goodbye.
Goodbye,
Bye,
sir.
sir.
Bye, sir.
Bye, sir.
Bye, sir.
Thank you po.
Goodbye.
Yes, sir.